Hello students, it seems Senti Abhyas test won't come now, so I'm utilizing it this time to prepare short revision topics for you. So the first topic I'm taking is communication system for the students who are appearing for JEE Main. Now in this chapter, you should first be familiar with the basic terms that are available on page 515 and 516 on your NCERT book, where you have that range, broadcaster, repeater, everything, the basic communication system you should know. Then you have a section called bandwidth of different signals. So just remember, for the normal speech signals, the frequencies that we typically use, we can speak from 20 Hz to 20 kilohertz, but in the normal conversation we generally speak in these ranges, 300 to 3100 Hz. So we typically take for a telephone signal, we take the bandwidth to be 2.8 kilohertz. Music signals, the typical bandwidth would be 20 kilohertz because you need that low and high frequencies both. For video signals, we have 4.2 megahertz if you have to transmit only picture, and for picture and sound you need a TV channel, that is 6 megahertz. That is for a typical SD channel. Now with the HD and other contents it might be much larger. Now for the propagation of EM waves, you have that ground waves, sky waves and that space waves. So here the basic formula that you should remember for the numerical point of view are: first is the critical frequency that can be reflected by an ionospheric layer, that is Fc is 9 root n, where n is the electron density, charge density, ion density, whatever density be given in the question. And if you have two transmitters of height ht and receiver of height hr, the maximum distance over Earth they can communicate over space waves is root 2 rht plus root 2 rhr, or the range of a tower can be written as root 2 rh, and the area covered type of question you have. Now in amplitude modulation, for numericals you need to remember what is modulation index, that is the AM by AC, or the voltage of the, you can say, message signal upon voltage of carrier signal, or Vmax minus Vmin upon Vmax plus Vmin. This is in the final modulated wave. Maximum voltage, minimum voltage, you have to take the difference and the sum and divide it. Bandwidth we typically take as the signal's maximum and the minimum frequency that is needed for suitable transmission. So bandwidth is 2 omega m, or basically I should write it as 2 times frequency of the message, or the highest frequency in the message you typically do. And if we take that frequency response curve, this is how the three frequencies are carried away. First is the carrier frequency, which has the maximum energy, and we have some energy in the lower sideband, which is Fc minus Fm and Fc plus Fm, that is called upper sideband. So just remember this, and their amplitude is slightly lesser. This mu is the modulation index. You can call it m or you can call it mu, that is one and the same thing, so both can suffice. So these are the basic formula sets that you remember. You need not to remember more than that. Other will be the theoretical ones. Now to take a very quick review of the questions, first of all see what are the type of questions that is being asked. See the first example. This is from JEE Main 2016 paper I am taking. We have a modulated signal. This is the final modulated signal. Modulating signal is the message signal, carrier wave is the carrier wave. This is the modulated carrier now you have, which we call as CMT. This is a form 30 sine 300 pi t plus 10 cos of 200 pi t minus cos of 400 pi t. The carrier frequency Fc, modulating frequency is f omega, message frequency Fm you can call, and the modulation index mu are respectively given by. So if you remember the expression, typically we have something like AC sine omega ct plus that mu AC by 2 into what we had, that sine or cos, whatever you write, cos of Fc plus Fm and Fc minus omega c plus omega m and omega c minus omega m type of terms that you can recall. So just looking at this, this would be the Fc omega c. So Fc would be 150 Hertz, and seeing from this, this would be Fc plus Fm. Fc plus Fm will come out as 200, and from here directly you can say Fm is equal to 50 Hertz. So Fm Fc you have got, so Fm is 50 and Fc is 150, so you are left with only this choice. And if you check the modulation index, the way I told you, this is AC and this is mu AC by 2. So mu times AC, that is 30 by 2, comes out as 10, so mu basically comes out as 2 by 3. So go for this option 2 that you can do based on this. So you need to remember what are the three frequencies available here that I told you in that above diagram. Next one, carrier wave of peak voltage 14 is used to transmit a message signal to achieve a modulation index of 80%. So modulation index of 80% means that would be equal to what we told, AM upon AC. So what we have, AM upon AC, so AC is given 14, so AM would be 14 into 0.8. So you have that 14 8s that you can do, 8 4s are 32, 8 1s are 8, 11.2 volts. So go for option 3 here. Now this is a very interesting question from JEE Main Online 2018. Just read it. Number of amplitude modulated broadcast stations that can be accommodated in a 300 kilohertz bandwidth for the highest modulating frequency 15 kilohertz. Whenever you are given highest modulating frequency, just remember the bandwidth of a channel is twice of this FM max. You can say the maximum frequency of the message or modulating frequency, that is 2 into 15, that is 30 kilohertz. So each channel requires 30 kilohertz. Now in 300 kilohertz at max, what you can put up, you can put up 300 by 30, that is at max 10 channels you can put up. Most of the student takes 20, but it should be 10. Remember this is an important concept. Now this is a self test based on what I have told you. Take a screenshot and try it yourself. I am taking going forward. Now this is a very special question from JEE Main Online 16 I am taking. See this question. An audio signal consists of two distinct sounds. You have two sounds. One is a human speech, which has a frequency from 200 to 27 hertz. The 27 hertz. There is a music signal which occupies 1020 to 15200, 10200 to 15200 hertz. The ratio of the AM signal bandwidth required to send both together to the AM signal required to just send the human speech. When you have to just send the human speech, you need this much. So the bandwidth required would be the difference of these two, that is 2500 hertz. This is required when only speech is required. Now when both are required, you need to transmit 200, you need to transmit 15200 as well. So the minimum frequency transmitted is 200, maximum is 15200. So to send them both together, you need the difference 15200 minus 200, that is 15,000 hertz. So that ratio 15,000 upon 2500 will give you 6. So go for the option third in this particular case. Next, a signal is to be transmitted through a wave of wavelength lambda using a linear antenna. The length of the antenna and the effective power radiated will be given respectively by. So what do you know? Typically what you have, the minimum antenna length should be equal to lambda by 4, that is for sure. You need a minimum length of lambda by 4, and we say the power is inverse to lambda square. For a given length of antenna, lesser the wavelength, more power would be radiated. This is a fact that you should remember. So based on this, power is 1 by lambda square, you are left with only one choice, and the minimum length is lambda by 4, you can have greater than that. So the first is the most appropriate out of this. So just remember, minimum antenna length is lambda by 4 and power for a given length of antenna is inverse to lambda square or proportional to f square. Now one more, a telephonic communication surface is working at a carrier frequency of 10 gigahertz. Only 10% is used for transmission, so only 10% means you have effectively 1 gigahertz available. How many telephonic channels can be transmitted simultaneously if channel requires 5 kilohertz? So if each requires 5 kilohertz, total bandwidth you have as 1 gigahertz. So you can have 1 gigahertz divided by 5 kilohertz, or you can write it as 5 into 10 raised to the power minus 6 gigahertz. That is the number of channel, that is 10 to the power 6 by 5. So that is 2 into 10 to the power 5. That is option 1 you can go for. Next one. This is a question asked in JEE Main Online 14 in 2 shifts. This is based on the fact that skywave is only applicable. Just remember, skywave is typically, we say, is applicable only for 3 to 30, roughly 30 or 40 you can have. So going by this, choose the most appropriate range. Both are of the similar time, the range is slightly differ, so you have to just check which is in the majority range. The frequency greater than 30 megahertz or 40 megahertz escapes to the space if they are not reflected back. Now some questions I am taking from the NT Abhyas test. See the first one. The maximum electron density in the ionosphere in the morning is 10 to the power minus 10. In noon it increased to 2 into 10 to the power 10. Find the ratio of critical frequency at noon to the critical frequency in the morning. So critical frequency I told you is 9 root n, that is proportional to root n. So this density is becoming twice in the noon. So frequency critical in noon to frequency critical in morning, because it has become 2 times, it would be root 2 is to 1. So go for option D directly you can do. And that formula I told you 9 root n, that you can remember. For an AM wave, the maximum amplitude is found to be 10 while the minimum is 2. That means in the final wave. So the modulation index, what we can say, Vmax minus Vmin, that is 10 minus 2 over Vmax minus Vmin, that will come out as 8 by 12. You can go for 2 by 3, option A. Now similarly this one, this is another type of question that is given in your NCERT as well. The height of a TV antenna is 200 meter, population density is 4000 per kilometer square. Find the population benefited. So first of all, the range of that antenna you say is root 2 RH. So that is root 2 R, that is 6400 kilometers. Keep it in kilometers only, that would be beneficial for us. that would be 0.2. So what you have, you can write it as 2 into 0.2, that is you can write it as 4 into 640. I can do, that would be better for us. That is the D. Now area that it can cover, roughly you will say is pi d square. Because of that small difference, you can take it to be radius. So pi d square, that is pi into 4 into 640 kilometers square. So the population benefited would be that area into population density, that would be pi into 4 into 640 into 4000, that you will get. So this is 1, 2, 3, 4, 10 to the power 4. What you have? 64 into 16 into pi. So what you can do now, you can directly check for the power. I think that is 64 into 16. If I do 16 4s are 64, 16 6 are 96, and 61024 into 3.14. So it would be 3000 something. So 3.2, 3 and 10 to the power 7. I can go for 3.2 into 10 to the power 7. That is the population that would be benefited. So these are some of the questions I have took in a very short time. I hope this will review up. You can please give me your feedback, how you liked it. If you liked it, I will try to prepare some short ones on some other chapters tomorrow also. Thanks for watching.